Namaskar, I am Anand and all of you are in the live class of Join for Education. In this class, I am going to solve 5 numerical problems of mechanical properties of solid. So let's see here. So let's see the question. First question. So this is the question number 6. You are seeing in your screen. I am going to read the question. The age of an aluminum cube is 10 centimeter. One face of the cube is firmly fixed to a vertical wall. A mass of 100 kg is then attached to the opposite face of the cube. The shear modulus of aluminum is 25 gigapascal. What is the vertical deflection of this face? So to solve this question, first of all, we prepare a data. Let's see. This is the question number 8.6. So we write down here. Let's see the solution. From question, it is clear that the question is saying that the age of an aluminum cube is 10 centimeter long. So here L equal to 10 centimeter. In a size system, this one will be 10 by 100 meter equal to 0.1 meter. Observe there is no problem to understand up to this step. The next sentence of this question saying that a mass of 100 kg is then attached to the face of the cube. This sentence clear the value of m. So we write down here m equal to 100 kg, and in this question we need what is the value of f. So f will be mg. Therefore we write down here 100 into 10 to the power, sorry, 9.8. The value of g is 9.8. So this one will be 980 Newton. After there is no problem to understand up to this step. The next sentence of this question saying that the shear modulus of aluminum is 25 GPa. It means that gigapascal. So this one also clear that shear modulus, which is generally denoted by Greek letter eta. So we write down here the value of eta is 25 GPa equal to this one will be 25 into 10 to the power 9. We write down here Newton per meter square. After there is no problem to understand up to this step, and the last sentence of this question saying that what is the vertical deflection of this face. So vertical deflection, it means that ask us what is the deformation and what is the value of del L. For this we take the help of a general figure. So we take the help of the figure from the textbook. So let's see. Now I am going to open the textbook to clear the figure. So of that you are seeing the figure of in your screen. So this is the 10 centimeter and ask us what is the value of this one. It means that del L, and this is the L. So we know that modulus of rigidity, also known as the shear modulus. So the shear modulus, which is generally denoted by G. So G equal to a stress by a strain. So we write down here. So we know that shear modulus, which is also known as the other name of the shear modulus, is modulus of rigidity equal to a stress by a strain. So this is the shearing stress and this is the shearing strain. So after the simple calculation, we get here a strain equal to a stress by modulus of rigidity or shear modulus. Now we recall the numerical value of the strain, which is del L by L. and numerical value of the stress is F by A. It means that force by area, and this is the modulus of rigidity or shear modulus. Therefore, here will be del L equal to F by A into, here will be nu into, we write down here L. After there is no problem to understand up to this step. So here we write down equal to F L by A into modulus of rigidity or shear modulus. Now putting the value of F, L, A and N to get the value of del L. So we write down here F, L, A and modulus of rigidity. So see the data. We find out area which will be equal to the L square. So the value of L is given here, M is given here, F is given here, uh, modulus of rigidity is also given here, A will be L square. So we write down here del L equal to 980 and the value of L is 1.0.1 by value of A will be 0.1 square into value of modulus of rigidity or shear modulus is 25 into 10 to the power 9. After there is no problem to understand up to this step. So let's see, here next step will be equal to 980 into 1, and for the decimal we remove the decimal, we write down here 1, and in the right hand side of the decimal we have one digit, so we write down here 10. Again the square of this one will be 0.01 into 25 into 10 to the power 9. Here next step will be, we cancelled out here this one, so this one cancelled out, and we write down here equal to 98 into 1, and we remove this decimal, for we write down 1, and in the right hand side we have two digits, so we write down here 20 by, we write down here 25 into 10 to the power 9. After there is no problem to understand up to this step. Now we cancelled out 25 4 ja 100, and the next step here will be, we write down here, we multiply 98 by 4, then we get 4 8 ja 32, at hand 3, 4 9 ja 36 plus 33 equal to 39. 36 plus 3 equal to 39. After that there is no problem to understand up to this step. Into we write down here 10 to the power minus 9, and this one will be in meter. So we write down this one in the standard form. So we write down here 3.92 into, we divided by 100 and multiplied by 100. So here will be 10 to the power minus 7 meter. So this one will be the answer of this question. So we write down here, this is the answer. Of that there is no problem to understand the solution of this question. Let's see once again. From question it is clear that L equal to 10 centimeter. So in meter this one will be 10 by 100 equal to 0.1 meter. M equal to 100 kg. So F equal to, we know that mg, and the value of g is 9.8 meter per second, meter per second square. So after the multiplication we get this one 980 Newton. The value of shear modulus is given in this question. Del L is asked in this question. We recall the numerical formula of the shear modulus or modulus of rigidity. Eta equal to stress by strain. Therefore, after simple calculation we get here strain equal to stress by modulus of rigidity. Now we putting the numerical value of the strain, stress, and after the simple calculation we get this one. So half that there is no problem to understand the solution of question number 8.6. Let's see the question number 8.7. Now I am going to open the textbook. Let's see the question number 7. So here question number 7 is in a screen you are seeing that question number 8.7. This is the question number 8.7. Now I am going to read question number 8.7. Four identical hollow cylindrical columns of milled steel support a big structure of mass 5000 kg. The inner and the outer radii of each column are 30 and 60 centimeter respectively. Assuming the load distributed to be uniform, calculate the compressional strain of each column. So this is very easy question. In this question ask us calculate the compressional strain of each column. So this question is based upon, we have three types of modulus: Young's modulus, shear modulus, and bulk modulus. So half that question number 8.6, 8.7, 8.8, 8.9, 8.10 based upon either Young's modulus or modulus of rigidity or shear modulus. So this question is based upon Young's modulus. So let's see. First of all, we prepare a data. So we write down here. Let's see the solution. From question, it is clear that again I am going to read the question. If you have NCERT textbook, then open. Four identical hollow cylindrical column of milled steel support a big structure of mass 50,000 kg. So this is the total mass of the four identical hollow cylindrical. In this question ask us what is the compressional strain of each column. So we find out mass of each column. So we write down here. From question it is clear that mass of each column 50,000 by 4. So this one will be 4 1 ja 4 and here will be 4 2 ja 8 and 4 5 ja 20 and we write down here 20. So this is 1000 12,500 kg. Of that there is no problem to understand up to this step mass of each column. So the force of each column will be here equal to F equal to mg equal to 12,500. The value of G is 9.8 in SI system. After there is no problem to understand up to this step. Now we find out area of each column or cross sectional area of each column. Equal to A equal to this is a hollow cylindrical, so we write down here pi r square minus r square. Here r is the outer radius of the column and a small r is the inner radius of the column. So we write down here pi and the outer radius of the column is given. This is the 60 centimeter. So we know that 60 centimeter equal to 60 by 100 meter. So we write down here 60 by 100 meter square minus 30 by 100 meter square. So this one will be the value of what? So this one will be the value of A, cross sectional area. Now we recall the formula of Young's modulus. So we know that here, we write down here. We know that Young's modulus, which is generally denoted by y, equal to a stress by a strain. Hope that there is no problem to understand up to this step. So in this question ask us what is the strain. So here a strain equal to a stress by Young modulus. So we recall the numerical formula of stress, which is F by A, and we write down here Young modulus. So in the textbook or in the question supply us a value of the Young modulus of the different material. So here in this question clear that a steel cylindrical column is made up of a steel. So we write down here Young modulus of a steel. So let's see the here next step will be a strain equal to the value of F is C here. The value of F is 12,500 into 98. Sorry, 9.8. So we write down here 12,500 into 9.8, and the we write down here the value of A is pi 60 by 100 minus 30 by 100 square, and the Young modulus of the steel is 2 into 10 to the power 11 Pascal. Hope that there is no problem to understand up to this step. So let's see the your next step. 12,500 into 9.8 by the value of pi is 3.14, and this is in the form of a square minus b square. So here will be a plus b into a minus b. So when we add this one, then get here 90 by 100 into a minus b. When we subtract, then we get here 30 by 100. After there is no problem to understand up to this step. After that we write down here 2 into 10 to the power 11. Let's see the next step. Equal to here will be 125 into 10 to the power 2 into 9.8 by here will be 3.14 into 9 3 is 27 into 10 to the power 2 by we write down here 10 to the power 2 into 10 to the power 2 equal to 10 to the power 4 into we write down here 2 into 10 to the power 11. However, there is no problem to understand up to this step. Let's see here 10 to the power 4, here 10 to the power 11, it means that we get 10 to the power 7, and 10 to the power 7 plus 10 to the power we cancel out 10 to the power 2, 10 to the power 2. So in the next step here will we get 1 to 5 into 9.8 by 3.14 into 27 into 2 into 10 to the power 7. After the simple calculation we get here 7.22 into 10 to the power minus 7. So we know that a strain is the ratio of length to length, so a strain has no unit. So this one will be the answer of this question. However, there is no problem to understand the solution of this question. Let's see once again. This is the question number 8.7 of NCERT textbook. Here is the solution. From question it is clear that mass of each column, force of each column F equal to mg equal to this one. Cross sectional area of each column which is A equal to pi r square minus r square, because column is in the shape of hollow cylindrical. We recall the formula of Young's modulus, which is stress by strain. So after the simple calculation we get here strain equal to stress by Young's modulus. The numerical value of stress is force per unit area or force by area. After putting the value of we get, this is the answer of this question. So hope that there is no problem to understand the solution of this question. So now I am going to over this class. Hope that this class will be useful to the schooling student of class 11.